So let's switch gears for a moment because your book, when is it coming out?
I hope in April.
Okay, so your book's out shortly, but this interview is likely out at the end of January, and so it's too much of a teaser. People aren't able to satisfy themselves immediately. And while I like being a tease, that's a bit too much of a tease. So I'll place a link on screen to your book, and I want to switch gears to ask you about their myriad questions that you tackle from my perusal of your career. So how does life self-organize? Is evolution merely Darwinian? How does complexity come about spontaneously, and where does agency come from, and is the universe creative, and what explains morphological diversity and consciousness's connections to quantum mechanics and so forth? There are a variety of questions here. What I want to know is, what is it to you that unifies all of these questions? What's the through line other than they came from you? Like, there must be something about these questions.
Curt, I really think I may have constructed a theory of quantum gravity and quantum cosmology. But let me briefly talk about that. I'm not a physicist. Chapter 5 is full of mathematics. Non-locality is now loophole-free. I started in 2019, but in that case, since 2022, said that non-locality is loophole-free. Then we have a choice. Either we say locality is fundamental, then we explain non-locality, or we say non-locality is fundamental. We have to explain locality. Move like, look, 2019, it's okay. Non-locality is fundamental. I mean by non-locality, there is no space. That's what I mean. Now just follow up with me with the beginning assumption. Watch how powerful it is. If non-locality is fundamental, then my assumption is any theory for which locality is fundamental can't be fundamental. It's kind of trivial. General relativity is fundamentally local. So if non-locality is fundamental, general relativity isn't a loop. Quantum gravity is local. Therefore, if non-locality is fundamental, loop quantum gravity isn't. String theory is local for the fact that it's got strings. For it to be fundamental,
The wonderful space formal field theory is in fact local. It's local on a d-1 dimensional manifold that it gives you the bulk because they're duals. But it's local on the d-1 manifold, right? All of them are ruled, and therefore also the holographic principle assumes locality, so it can't be fundamental. That doesn't mean my assumption is true. It means that if you start with it, you rule out almost everything, which is really interesting. It's very powerful. Causal set theory is allowed because so the move I made was two. You know Heisenberg's interpretation of quantum mechanics in 58? The quantum state are potentia, ontologically real potentia, right? So I assume that also. I do because it's an immediate explanation of superpositions. Here it is: the cat simultaneously alive and dead. Well, that disobeys Aristotle's law of the excluded middle and non-contradiction. Try the cat is possibly alive and possibly dead. That's not a contradiction. So it gives a trivial interpretation of superpositions, and it answers the six mysteries, which way information and that. This is in chapter 2. So just take those. The move I made is to say that which is ontologically real and is not space-time are possibilities in Hilbert space. Okay, so I take that, and now if in fact what's in Hilbert space, it's not are possibilities, how do you ever get anything actual? Decoherence doesn't do it. You're left with finite off diagonals. The only thing that gets rid of potentia is quantum measurement, is actualization. Well, actualization happens. We just don't know what the hell's going on. So actualization, I say, is real. What quantum measurement is doing, if you say this, is converting possibles to actuals, which is ontological. It's not epistemic. So the basic move I make, Curt, is I'll just tell you what I do.
Sure.
I got 4 mutually entangled particles. There's a reason. They sequentially actualize and stay entangled until they actualize. And I'm going to map von Neumann entropy, or better, mutual information. There's 6 entangled pairs. I got 4 things that are all entangled, so there's 6 pairs. So in the book, I see von Neumann entropy. A better choice is mutual information. It's symmetric. I simply map that into a linear distance.
So you get 4 events, A, B, C, D, 4 events, okay? And they're actual events. And I use the von Neumann entropy. So I get the mutual information between them and the potential to be actual distances of some length deal. So I get 4 events, 6 actual distances, and I learned about the Graham matrix. They didn't teach me as a biologist. You can take the actual distances, the absence of it. You can get the metric tensor. That's from the 6 distances. It turns out that the metric tensor is Lorentz invariant because it seems disentangled. It also is de Sitter space, not anti-de Sitter space. And it turns out it also fits the Bianchi identities we've learned about. This is kind of remarkable, as no theory is done. No theory. It only gets the metric tensor. So that's pretty interesting. Then I use, in this chapter 5, I learned about regicalculus. So as theory builds tetrahedra, the tetrahedra can share a space with another tetrahedra. So space-time constructs itself and grows, and it can be the case that it grows. Every tetrahedron is on average 1.5 points, so it's one-dimensional. Or occasionally, it could be higher dimensional. I wound up replacing Einstein's cosmological constant space-time explores space-time with a modified cosmological constant, which space-time spans a portion of the 4th root of matter density. So it's in learning about Bianchi solitons. It seems to unite dark energy with dark matter and inflation at the construction of space-time. It seems to prevent singularities in black holes. It seems to help the XA tension, the Hubble tension, a bunch of other things. It may be right. The math in chapter 5 has to be completely checked. I can't check it. I also wound up with data that really challenged lambda CDM. So that's all in the book in chapter 5, with kind of the debate we get looked at by somebody who's competent. I'm a biologist. So the throughput in all of this is if it is right. Space-time constructing it into an adjacent possible that is deterministic.
Life is constructing it into an adjacent possible that can't be perceived, and then possibly mind. There's something about the indefinite. I don't know that that applies to the physics part. And I don't know what to make of the whole thing. Maybe it's a complete crock.
And indefinite here is then a synonym for the possibility space?
Well, I mean the indefinite for the possibility space where, in fact, it is indefinite. I don't think that's true in quantum mechanics. Quantum mechanics can be context dependent, but there's no new possibilities that arise in quantum mechanics. So I don't know. There's some kind of becoming going on everywhere, Curt. It's not being. It's not an entailed trajectory in a pre-stated phase space. It's not the block universe where nothing becomes at all.
Hi, everyone. Hope you're enjoying today's episode. If you're hungry for deeper dives into physics, AI, consciousness, philosophy, along with my personal reflections, you'll find it all on my Substack. Subscribers get first access to new episodes, new posts as well, behind-the-scenes insights, and the chance to be a part of a thriving community of like-minded pilgrimers. By joining, you'll directly be supporting my work and helping keep these conversations at the cutting edge. So click the link on screen here, hit subscribe, and let's keep pushing the boundaries of knowledge together. Thank you and enjoy the show. Just so you know, if you're listening, it's CurtJaimungal.org, CurtJaimungal.org.